Chapter 13. Debugging. More important than you think. Debugging is the name given to the process of finding errors in programs where they don't run. One of the most frustrating experiences in programming is to spend a lot of time writing a program, then having it run but not get the results you expect and wonder why that happened. Before I talk about the necessary steps in debugging, let's start by classifying the types of errors that are typically found in programs. Once you understand the differences among these three errors, you will better understand how to find the errors associated with each. In this chapter, definition of debugging, syntax, runtime and logic errors, how to debug, tracing. 3 types of errors. There are 3 types of errors you get when you run a program: syntax errors, logic errors, and runtime errors. Let's look at definitions and examples of each so that we can learn how to eliminate those errors through debugging techniques. Syntax errors. Syntax errors are the easiest errors to spot, since you will probably have the aid of a compiler to spot them. Even if you don't have a compiler, you will probably have some aid in checking the syntax. A syntax error is a grammar error. Just as you can make a mistake when you misuse English grammar, you can make a mistake in the grammar of the language in which you are programming. Let's look at the typical syntax errors that programmers make. Spelling errors. If you misspell a word in a computer language, specifically a reserved word that has a built-in purpose in the language, you will get a syntax error. For example, look at the following misspellings: knit instead of not, lete instead of let, newe instead of new. A computer has no innate intelligence. It will not examine your misspelled word and think you must have meant the word new instead of the newe that you wrote, unless you program it to do so. Punctuation errors. Punctuation errors can be harder to spot unless you like looking at small exacting code. Here are a few examples. X equals x plus 1 instead of x equals x plus 1. If y is less than 6, see out hello instead of if y is less than 6, see out hello. I'm not sure how those two are different. X equals x plus 1 has first a period, then a semicolon. And the same thing, actually, if y is less than 6, the 6 doesn't have the parentheses after it in the first example, but it has parentheses after it in the second example. In the first example, the final period should have been a semicolon. In the second example, there should have been parentheses on both sides of the Boolean condition, y is less than 6, instead of only one side. The compiler will help you to find these simple errors because it is easy for a machine to spot symbolic differences. It will be harder for the compiler to find the other errors, though, like runtime errors and logic errors. Tip: it's best to correct the first error caught by the compiler and then test your program again, recompile, rather than trying to correct multiple errors all at once. Why? Any code later in the program that depends on data related to the earlier error will probably also generate an error. Runtime errors. Runtime errors are errors that arise while a program is running. That is, they are discovered only as the program runs. They are not easy to spot because they are not syntax or grammar errors, which the compiler can spot easily. They are subtle errors and develop in the course of the program's execution. The typical runtime error is the division by zero error. If you write a program, for example, where you are trying to calculate the average of some number of test scores, you might have a program fragment written like this: x is equal to x plus 1, y is equal to sum divided by x, C out, y, and L. Notice how x was changed just before being used in the division statement. Unless you know that x is always positive and therefore greater than 0, you can't assume that at some point x would not take on the 0 value, causing this algebraic problem. Y is equal to sum divided by 0. Yikes! Some compilers might even recognize this error, but you should recognize it first. Here is how you can amend your program code. X is equal to x plus 1. If x is not 0, opening brace, y is equal to sum divided by x, C out, y, and L, closing brace. A simple statement like if x is not 0 will go a long way in helping you to program more cleanly and efficiently. Logic errors. Logic errors are the most difficult to spot because programs that contain logic errors have no problems running and are never spotted by compilers. A logic error is the type of error that only the programmer can recognize. He runs his program, gets results, but knows that his program did not do what he wanted it to do. So the program did not execute his logic or his thinking. It's really his fault, but he doesn't know that yet. Let's look at a typical logic error and then address how we can fix it. Here's a program fragment where you compute the average of 3 test scores and then you print the result. Num score equals 3. C out. Please type in your 3 test scores. C in. A, B, C. Average equals A plus B plus C divided by number scores. See out. The average is number scores and 9. So what's wrong with this fragment? There are C out and C in statements and the grammar is correct. What will happen when you run this fragment? You will always get a 3 printed on the screen. You might try typing in different values for test scores, but you will start to notice that you always see a 3 on the screen. It might seem really easy to you and not worth mentioning, but the error is a very simple one to overlook. It is the last cout statement that causes the logic error. We should have printed the variable average, not the variable num scores. That's where the logic error is. See figure 13.1. Figure 13.1. The programmer thinks of different test scores, but notices that the screen always shows the number 3, which makes no sense to him. Let's look at the drawing. Y3, 82, 85, 91, 7, question mark. The average is 3. So how do we avoid the logic error? The easiest way to do so is to track through your program by putting some output statement in judicious places. Output statements will allow you, the programmer, to see what is happening while it is happening, to help you better understand what the error is. Look at the same program fragment, except this time you will see some additional output statements. Num scores equal 3. See out the value of num scores is num scores end line. See out. Please type in your 3 test scores. See in A, B, C. See out A, quotation marks, B, quotation marks, C, end line. Average equals A plus B plus C divided by num scores. See out average, end line. See out. The average is num scores, end n. The addition of output lines will help this programmer realize that he made a mistake in the last output statement where he should have printed average instead of num scores. It's a good habit to use print statements to help yourself see what the computer is doing, in a sense. Of course, if the development platform you use, that is Visual Basic, has a debugger, you'll want to use that as well. What are debuggers? Debuggers are an additional utility or tool that come with your programming language. They allow you to stop or halt program execution in progress. They allow you to stop or halt program execution in progress. This is a powerful tool because you can get a window into what the compiler is doing as it runs your program. You can often see what values are in your program, and you can watch them as they are changing. This proves to be very useful, since it is often the unexpected value of a variable that causes an error for a programmer. So whether you have a debugger or not, you can simulate what a debugger does by adding a few output statements to your program. These statements act as windows into your program. They allow you to see the values of variables and how they are changing. As you learn more about how to organize your program, and as your programs increase in size and complexity, it is important to know how to debug well. Otherwise, you will spend a lot of time and frustration trying to find out what went wrong. Tracing through a loop. A lot of problems in programming arise when using a loop. A loop always changes the value of the control variable. One good idea is to put an output statement into a loop so you can watch the values of the variable as it changes during the loop's execution. Here is an example. For x is equal to 1, x is less than 25, x plus plus, opening brace, average equals sum divided by x, see out. X has this value, x and L. See out. The average is now average and L, closing brace. In the preceding example, the two output statements make it easy to see that both x and average are changing. It might seem like a trivial thing to do, but it helps a lot. Here is another example of using a trace inside a loop, a while loop. While x is less than 25, opening brace, average equals sum divided by x. See out, x has this value, x and L. See out. The average is now average and L. X is equal to x plus 1, closing brace. Consider what would happen in this badly written fragment. See in x's value is set by the user, while x is not 25. Opening brace, average is equal to sum divided by x. See out has this value, x and L. See out. The average is now average and line, x is equal to x plus 1, closing brace. There are a few problems that you might have spotted. The value x was set by the user, and then it is used as the control variable of the loop. The programmer has no control over its initial value. Secondly, the Boolean condition of the loop is too general, allowing the loop to spin simply when x does not equal 25. When x does not equal 25 is not as specific as it should be. We need to stick with a more restricted comparison. X is less than 25 and so on. Tracing through a function. As your programming becomes more complex, you will have to watch values of variables as they are being passed into a function. You might need to put some output statements before and after entering a function. In Chapter 8, you learned about functions and how they are designed to do work outside of the main section of a program. Look at how we have used some output statements to clarify the values of the variables as we run the program. Int main, opening brace, int x result, see out. Please type a number for which we will find the square end line. See in x, see out x end line. We put this here to see x's value. Result equals square x. See out. The result of the function is quotation marks result end line, closing brace. Int square int m, opening brace. See out. m and l, we check the value of m. Int answer m times m. Int answer is equal to m times m. Cout answer, return answer, closing brace. By inserting these extra output statements, you can check your program each step of the way to make sure that it is working properly. We are simulating what a debugger does. It allows you to stop and view variables and their values at intermediate points. Sometimes you have to clarify a variable's value if it is changing both within and outside of a function. Here is a suggestion of how to clarify those changes. If you have the same variable that you are passing back and forth, use descriptive statements that indicate where you are in the program. For example, cout. The value of x inside the alpha function is x and l. Or cout, the value of x just after leaving the alpha function is x and l. A few statements like the ones in this chapter will be extremely helpful to you as you continue to program. Summary: a debugger is a program that you can use to help you find bugs or mistakes in your program. There are 3 types of common errors in programming: syntax, runtime, and logic errors. Syntax errors are the easiest ones to find. The compiler will spot the grammar error right away. Runtime errors only develop as a program is running, so they are not found by the compiler. Logic errors are the most difficult to find because only the programmer knows whether she did the right thing or not as far as her intent. Adding output statements as a way of watching the variable's values is a good technique for debugging. Using the existing debuggers with your language application is the best.